So part of trigonometry is solving trig equations, and to be able to solve trig equations, the main things that you need to know is you need to know when each of the ratios are positive and when they're negative. So to do that, we have what we call the cast diagram. So these are our quadrants. We've got 0 here, 180 degrees on the other side, and then of course 360 degrees around here. If it was radians, we would have 2 pi where 360 is and pi where 180 is. But it's basically understanding that any like all of the ratios are positive in the first quadrant. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. And that's purely because if we remember from our unit circle, sine is read off of the y-axis. So of course, when it's at the top, in the top two quadrants, sine will be positive because that's the positive y-axis. If we look at cosine, cosine will be positive only in the right-hand side of the quadrants because it's read off of the x-axis, which is when the x-axis is positive. We also have tan, and tan, remember, is sine divided by cosine. So tan becomes positive in quadrant 3 because both the sine value and the cosine value will be negative. And if, of course, if we divide a negative by a negative, we get a positive. So committing that to memory, that diagram, is super important because it helps you also recognize when obtuse angles are negative, whether obtuse angles are negative or positive, whether acute angles are negative or positive, and it also helps us answer questions like this first example. Solve sine of x equals 1/2 for 0 to 360 degrees. Now, there's a couple of things you need to know when you're solving trig equations. Of course, one of them is the cast diagram. The second one is your reference angles for exact values. So here, if we look at sine x equals 1/2, our reference angle is 30 degrees because sine of 30 is equal to 1/2. So we write down our reference angle, and of course, I'm using degrees because our domain here, the 0 to 360, is in degrees. We then draw up our cast diagram, so our quadrant. And if we go back to our previous screen, sine is positive because the answer here is positive 1/2. Sine is positive in the top two quadrants. So what we do is we draw in our reference angle as 30 and 30. So we're looking at from 0 to 360, which is one full rotation, or revolution, I should say. So that means our two solutions for this particular example would be x equals 30 degrees, and then we would do 180 take away 30, because of course we're going backwards from the 180 line. So we would have x equals 150 degrees. So two solutions for sine of x equals 1/2 for the domain of 0 to 360 degrees. If, for example, it was looking at 0 to 720 degrees, we would then go around again, and we would notice that our next solution would be 390 degrees. Of course, that's 360 plus the 30. And then we would also have to add in that last one as well. For example 2, we've got solve 2 cosine x equals negative root 3. And we've now got a domain from 0 to 2 pi. Now, the important thing here is the domain is in radians, which means our reference angle needs to be in radians. But before we do that, we've got this 2 that we need to look at. We need to get cosine of x by itself. So our first job is to move the 2 to the other side. So we would have negative root 3 on 2, which now hopefully you should be recognising that root 3 on 2 is an exact value. So our reference angle for for cosine, for when cosine is equal to root 3 on 2, is pi on 6, because it would be 30 degrees. But of course, we've got a radians domain, so we need a radians reference angle. Again, we draw up our cast diagram. If I draw up my cast diagram, we've got a negative here. You can see I've circled the negative value there for you. The negative means that we're looking for when cosine is negative, which if we go back to our cast diagram, cosine is negative in quadrants 2 and 3, which is the left-hand quadrants. So I would draw my reference angle in here and in here, pi on 6. We also need to recognise that these values here are now 0 and pi, and of course 2 pi. What we need to do, because we're working with fractions and we're looking at trying to do these without a calculator, we need to work out what can we make, how do we make pi if we want it as a fraction out of 6. So here it would be 6 pi on 6, and over this side we would have 12 pi on 6 to be able to get 2 pi and then pi on the left-hand side. So now what we're looking at for our solutions is we would have 6 pi on 6 take away pi on 6 to get this first one here, which would give us 5 pi on 6. And our second solution would come from doing 6 pi on 6 plus pi on 6 to get that second solution, which would become 7 pi on 6. So they would be our two solutions for when cosine of x equals negative root 3 on 2. It would be at 5 pi on 6 and 7 pi on 6. Those two examples were quite straightforward. This last example here, solve tan 3x equals root 3 for 0 to 2 pi. So the only difference here is we've got a number in front of our x. So what that actually does for our working is, because it's a 3, it's going to triple the domain. If it was a 4, it would quadruple the domain. If it was a 2, it would double the domain. So we're now looking at, when we're doing our working, between 0 and 6 pi. We also need to know our reference angle. So in this case, our reference angle is pi on 3, because we're looking at when it would be 60 degrees if we were looking at degrees. And we've also got its positive root 3. So if I draw in my cast diagram, tan is positive if we go back to the first screen. Tan is positive in quadrants 1 and 3. So we would draw in our reference angle here at pi on 3, and same out here, pi on 3. We also need to remember that this is now 2 pi, 4 pi, and 6 pi when we do our 3 revolutions. And again, if we want that as something out of 3, we would have 6 pi on 3, 12 pi on 3, and 18 pi on 3. Of course, this part here is not necessarily required as part of your working, but for me, it makes it easier when we're looking at subtracting fractions. And then, of course, on the other side, we would have pi, 3 pi, and 5 pi, which will give us, I'll write them down here, we would have 3 pi on 3, 9 pi on 3, and 15 pi on 3. So these yellow values are actually up here on that x-axis. What we then do is we can go, okay, so that means that the value of 3x is going to be, if we start, we would have pi on 3 as our first solution. We then go around, we would have 3 pi on 3 plus pi on 3, which gives us 4 pi on 3. So that's one rotation done. If we then go to around again, we would be at 6 pi on 3. And if we're adding pi on 3, we would get 7 pi on 3. And then if we go around to the third quadrant again, we would have 9 pi on 3 plus pi on 3, which gives us 10 pi on 3. So that's the second rotation done, or revolution done. The third revolution would be 12 pi on 3 plus pi on 3, which is going to give us 13 pi on 3. And the last solution would be 15 pi on 3 plus pi on 3, which gives us 16 pi on 3. So we've actually got 6 solutions for this particular question. However, what we would need to do to make sure we actually finish this question off is, at the moment we're saying 3x is equal to all of those things. So to get our actual final solution, we would need to divide each of those angles by 3, which would mean we would end up with pi on 9, 4 pi on 9, 7 pi on 9, 10 pi on 9, 13 pi on 9, and last but not least, 16 pi on 9. And they would be all of our solutions for that particular question. And you can see that all of these solutions now fit in the original domain of 0 to 2 pi, because 16 divided by 9 is still less than 2. It's actually about 1.8. So we would have 1.8 pi, which is still less than 2 pi. So all of these 6 solutions are relevant for this particular question. So just remember, if you've got a straightforward one like example 1, very easy, write the reference angle, check if it's in degrees or radians, determine what quadrant you need to be working in, and then determine the solutions. You then need to, for example 2, we need to check if we've got a number out the front before we start. Can we move it over to get an exact value? And then lastly, we need to make sure if there is a number in front of the x, that we then triple, in this case, triple the domain, or we adjust the domain for that value, and then we work out all of our solutions. So I'll just put a box around here. The final solution here is those ones in the red. So hopefully that helps with solving the trig equations. Again, the additional fractions around 2 pi, 4 pi, 6 pi, 3 pi, etc. Obviously, if it was pi on 6 as a reference angle, you would want to make all of them as something out of 6. It just helps with the addition and subtraction of fractions if you're having to do this without a calculator. If you had to do it on the calculator, very simple, Action Advanced Solve on a class pad, calculator in the main menu, make sure you're set in degrees or radians depending on the domain, and of course you still need to put given and put the domain in, because if you don't do it, your calculator will try and keep finding solutions because we would have an infinite number. So hopefully you have a good understanding of solving trig equations, and remember to commit that cast diagram to memory.